Welcome to Chapter 2, and at the beginning we are looking at frequency distributions and tables, and quickly in the next section you'll find that we will be making frequency histograms. So there are three types of tables. There's a regular, I call regular, but it's just a frequency table, a relative frequency table, and a cumulative frequency table. You want to know the three types, maybe take notes on what the differences are. They are all tables that will take data and count how often a certain value occurs within a certain range of values. So these ranges in this table that you're being shown are 0 to 14, 15 to 29, and the way they take a set of numbers and make little intervals, and they define those intervals as different classes. And so what you see is this is a frequency table. What if you read the top of the table, it tells you that the original range of numbers that we're looking at are the different times that people could be sitting in traffic on their commute in LA. I guess it didn't say that they were sitting in traffic, but I'm assuming if it's Los Angeles that they are in a lengthy commute, and probably some of that time is sitting. Anyway, so you have a certain number of drivers, and what this table is doing is it's telling you out of the sample of drivers that they have information about, 6 of those drivers have a commute time anywhere between 0 and 14 minutes. 18 have a commute time anywhere between 15 and 29 minutes. So some of the questions that you're going to be having to answer in the homework have to do with very specific parts of this table. The lower class limits and the upper class limits are all the numbers either that begin the interval or end the interval in each class. So the lower class limits, if you have to answer that question, would be 0. Sorry for my handwriting. I'll do better next time. 15. I'm going to put ... because my handwriting is horrible. So 0, 15, 30, 45, 60, 75, 90. Those are all your lower class limits. And then your upper class limits are 14, 29, 44, 59, 74. The class boundaries, the midpoints, and the width are a little bit more challenging. So these two I'm going to hold off on describing, and the class width, I'm going to get right to it. So the class width, you don't look within every single individual class. When you're looking at class width, you want to look at the difference between the lower class limits, 0 to 15 to 30 to 45. They're going up by increments of 15, and that's what you refer to as the class width. And what you would also see is the upper class limits. Those also would go up increments of 15. So that's what's referred to as the class width. Now the class boundaries and class midpoints, a little bit more specific. Let me exit my drawing. Sorry, I'm fumbling a bit with my drawing tools here. This is so very blurry, I apologize, but what's being shown here are the boundaries. So when I first mentioned that this table's displaying people whose commute time is anywhere between 0 and 14. And then I went to the next class and I said 15 to 29. What about those people that were 14 and a half minutes or 14.2 minutes? And so that's kind of what these class boundaries do, is they allow for that, the numbers in between, basically. So if you're trying to calculate them, as the textbook, sorry, this is so blurry, is showing you, you split the difference. So beginning with the difference from the first lower class limit and whatever increment that you need to get between the two classes. So In this example, I'm trying to answer the question for the boundaries, and the boundary between 14 and 15 would be 14.5, and then the next boundary would be 29.5, and then the next boundary would be 44.5. So that 0.5 is what you also use when you describe the very first boundary. So again, these are 5 things very specifically that they're going to ask you about a frequency table. And I'll go back and answer the boundaries and the midpoints by handwriting them in. But most generally, what a frequency table is that it takes quantitative data, and that data could be viewed on a number line, and it chunks up the data into different intervals, and it tells you how many of the data points are within that class. And so you don't know specifically what these 6 people's actual commute times are, but nor is that specific information going to be displayed that often, right? If you end up having 100 or 1,000,000 data points, it's okay to cluster, 0 to 14 minutes, 15 to 29 minutes. So it's a way to classify. And then it's also a way, as you'll see in the next section, to display the data. So try not to get too tripped up on these specific questions. You will, like I said, have 2 or 3 or 4 of your homework questions that are asking about these details. So the lower class limits, that's all the left numbers, right? The upper class limits, that's all the right numbers. The class width, that's the distance between either one lower class to another lower limit, one upper limit to another upper limit. And then the boundaries, in this case, let me write them in, would start with negative 0.5, because 0.5 would be how you would split the difference between the 2 classes here. So negative 0.5 would be the first class boundary, 14.5 would be the second class boundary, and yes, you will have to type every single one in, but it's not like every single question is like that. And then I'll go ... Okay, hopefully you know how to calculate the rest. The midpoints of each class are exactly what that is like what's the number that's exactly between 0 and 14. So if you want to know basically what you're calculating, it's the mean, scribble, scribble, it's the mean of... Sorry, I'm going to continue with this, but I'll do better next time. The mean is when you add the lower class limit and the upper class limit, and then you divide by 2. Now, very often, I am kind of able to split the difference in my head. So the first class midpoint would be 7. And then the next class midpoint would be if I were to take 15, and then I would add 29, and then divide that by 2. And then that would be 30, 44 divided by 2, that's 22. And that's the number that's exactly between the lower and upper limit of the class. What is also true is the class midpoints go up in the same increments as the lower class limits, the upper class limits. And so what I could do is just add 15 to each midpoint to get to the next midpoint. So if I added 15, this would be 37, and that would be the next class midpoint. So the class midpoint is the value that is exactly between. It's the mean of the lower and the upper class limit. Okay, so again, a frequency table takes data, and what it does is it groups it into different intervals going from least to greatest. Apologies again, that's a very blurry slide there. Again, class width, caution from the textbook, is not the difference between 0 to 14. The class width is going from the lower limits of each class, and that is how I describe the increments. Okay, so that is a relative, just a frequency table. And what you see here is the description of what the difference is from a frequency table to a relative frequency table. So a relative frequency table has the same classes. As you see, the left side, the left column is showing the same data. But frequency table tells you exactly how many people were in that category, where a relative frequency table gives you the percentage of total people. And so the upside or the pro of having a relative frequency table is that the point of these frequency tables is to do groupings. And so now you can say, 36% of the commuters have a commute time between 15 and 29. So it allows you to make more broad statements, but you don't know how many people were included in the survey or the study. Whereas in a frequency table, you can actually add these all up, and then you'll know exactly how many people were total originally asked. So how do I get from one to the other, right? So to create a relative frequency table from a frequency table, I first need to know what the total number of people were in the frequency table by adding, and you'll forgive me, I'm not doing this under the camera, but I'm just adding 6 and then 18 and then 14 and then 5 and 5 and then a 1 and then a 1, and I'm getting a total of 50. So to move from a frequency of 6 to a relative frequency of 12, what you would do is find the percentage that 6 is out of 50, or you could just take 6 divided by 50 and you'll get that 0.12. That's represented as 12%. When you do this by hand, I will accept the 0.12 or the 12% when you're doing it on the MyLab. See what it is that they prefer that you do. So the sum of percentages in a relative frequency distribution should be very close to 100%. They say there's a little bit of wiggle room in the event that there's some rounding. These are whole percentages, so if you had to round up a couple of times, you might be at 101%. But you shouldn't be anywhere, like in 110% or 70%, and that would show you that the relative frequency table was calculated incorrectly. And so moving to what a cumulative frequency table is, the word relative is not involved here. So cumulative means adding them up. And so what you see are two totally different columns of data in a sense. My left column is still talking about daily commute times, but instead of breaking them into classes as distinct, 0 to 14, 15 to 29, what you see in a cumulative frequency distribution is it'll clump up all of the people less than 30, all of the people that have a commute time less than 45. And so when you look at the very last column, the last row in this first column, the number of people that have a commute time less than 105 is all of the people. So if I, again, am given a frequency table, and I'm trying to go from here to building a cumulative frequency table, this 6 is still exactly the same. But the reason why the cumulative frequency has a 24 is by adding the 6 people in the first class to the 18 people in the second class. So that's where this 24 came from. And it is true that all 24 of these people had a commute time that is less than 30, right? All of the people in this table had a commute time less than 105. And so that's how you would come up with the right side, with the right column of values, is you just take the value that's in the row that you want and you just add all the numbers above it. Hopefully that made some sense to you. So in the last section of this section, the last portion of this section, they begin to talk about the all-important normal bell curve. So a frequency distribution can help you understand the way that the data in a data set is distributed, which is the nature or the shape of the data, which we'll talk a little bit more about in the next section. But they want to take every opportunity possible to refer to this normal bell curve. It's very important in this course. So it states that in statistics, we are often interested in determining whether data it lies in a normal distribution, because if it does, there's a lot of things that we can do with the numbers. So normal distributions are discussed extensively in chapter 6. They're the basis of chapter 7 and 8 as well. And that's why we're talking about them right now in chapter 2, because they're so important. Data that have an approximately normal distribution are characterized by a frequency distribution with the following features on the next page. But as we've been talking about frequency table, this down here is where you would see the range of values. We were talking about commute times, right? So this would be the people that had a commute time of 0 minutes, 1 minute, 2 minutes, 3 minutes. So that's like the number line. When you're looking at the bell curve, this right here would be the number line. Not to say that the table we were talking about was normally distributed, but in any normal bell curve, the bottom of the curve represents the horizontal axis, or like a number line. And what would happen in a normal bell distribution, if you had a frequency distribution that was normally distributed, is that most of the data would lie where the middle of the numbers are. We went from 0 to 105 in the last frequency table. And so this would be about 52.5, right in the middle. So the frequencies that are normally distributed when they're shown in a frequency table would start with low values, and then towards the center of the table you would see the largest amount of people would fit in that interval. And then the other thing is that it's roughly symmetric. There are a lot of ways to split numbers into intervals, and so a rough symmetry is what you want to describe. A normal bell curve is perfectly symmetric, but if we want to say that things are roughly normal, they would be roughly symmetric. Again, I apologize. I don't know why these are coming up so blurry, but what you see here is 0 to 14, 16 to 29, 30 to 44, and the frequencies are symmetric. So there's 2, 4, 10, 18, there's another 10, there's another 4, there's another 2. So this is what a frequency table would look like that was displaying a normal distribution. So this is basically the end of the lesson. Again, remember the 3 different types of frequency tables are the basic frequency table, where the values over here are telling you how many values of the data set lie in each category. You've got the nitty-gritty specifics, the upper lower class limits, the boundaries, the midpoints, and the class width. And so at the end of this lesson now, you are reconsidering the daily commute times and answering the question of whether or not you believe the commute times fit a normal bell curve, or are symmetric. So the highest value in the first table that we looked at, the frequency table, was in the second class. And so this is not a normal distribution. It's far from symmetric. And so the original frequency table, not every frequency table is going to fit a normal bell curve. So that concludes the slides here for this section. Jump on in and do the homework, and always let me know if you have any questions.